Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to solve systems of equations algebraically using the elimination method. How are we learning it? Through the systems of equations using Elimination Part II notes and the systems of equations using Elimination Part II assignment. When can we use this information? To find economic solutions to financial problems, such as income versus expenses and supply versus demand. How do you know you learned it? By getting a score of 4 on the systems of equations using Elimination Part II assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. After that, we'll take some time to go over the solving systems of equations using Elimination Part II notes, and then I'll give you time to complete the solving systems of equations using Elimination Part II assignment. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Systems of Linear Equations study guide and any incomplete assignments that you may have. Let's take a look now at the solving systems of equations using Elimination Part II notes. The notes begin with the learning goals and success criteria.
Now let's take a look at how we can graph systems of linear equations. So all this really means is we're going to graph both of these lines at the same time. So on the first one, we'll go ahead and graph this. So we're going to plot our y-intercept, which is -2. So we're going to go down 2 and plot our point. And the slope is 1/3. So we're going to go up 1 to the right 3, plot our point, and connect the dots. So just like we did earlier, that's the same thing we're going to do now. Now, we're just going to plot the second line on the same graph. So my y-intercept for this one is 3. So I'm going to go up 3 and plot my point. And my slope is -1/2, so I'm going to go down 1 to the right 2, connect the dots, and notice now I have a point where they intersect, which is right there. That is considered the solution to the system of equations. Now let's talk about how we can solve this without having to graph. So if we're given something like this, 3x minus 2y is equal to 24, and 3x plus 2y is equal to 12, we're going to go ahead and solve this using what we call elimination. So here are the steps. First step is we're going to check for opposite x values or y values. Now opposites mean they have the same integer but with opposite signs. So for instance, we have a +3 and a +3. Those are not opposites. We have a -2 and a +2. Those are opposites. So these two represent opposites. So if we have opposite x or y values, we're going to go ahead and add the equations together. So we're going to add the entire equation. So we'll add these up. So we add 3x plus 3x, and we get 6x. -2y and 2y is equal to 0, right? So that's the elimination part. We eliminated the y's. And then 12 plus 24 is 36. So we end up with 3x is equal to 36. Now we're going to solve for x. So 6 is being multiplied by x, so I undo it by dividing. So we divide both sides by 6, and we get x is equal to 36 divided by 6 is 6. So that's x. Now we know the x coordinate of where they cross, but now we need to get the y coordinate. So we're going to plug 6 in for x into one of the two equations. It doesn't matter which equation you pick as long as you plug in x as being 6. So we'll go ahead and pick this one. We'll pick the first one. And we're going to plug 6 in where x is. So instead of being 3x minus 2y is equal to 24, it's going to be 3 times 6 minus 2y is equal to 24. So 3 times 6 is 18. So we get 18 minus 2y is equal to 24. We need to get rid of this 18. So we're going to subtract 18 to get rid of that. And we're left with -2y is equal to 24 minus 18 is 6. We'll divide both sides by -2, and we get y is equal to -3. Now let's take a look at another example. So we're going to check for opposite x values or y values. So we have a +1 and a -2. Well, they have opposite signs but not opposite values. We have a -1 and a -1. So again, we don't have opposite values. So if we don't have opposite values, we're in trouble. So what we need to do is we need to create opposite values. We need to multiply either one or both of the equations by some number to get opposite values. So in this case, the easiest looks like it might be the y's, because we could just multiply one of these by a -1, and that gives us a +y and a -y. But we could also do the x's. We could multiply this whole thing by 2. That gives us a +2x and a -2x. But we're going to go ahead and do the top one by -1. If we multiply the top one by -1, we get positive y and negative y. Now, here's the deal. Anytime we multiply this, we have to multiply everything. So that's the x's, the y's, and the constants. Everything's got to get multiplied. So when we do that, we get -1 times x is negative x. -1 times negative y is positive y. And -1 times 11 is negative 11. So what we're left with now is negative x plus y is equal to negative 11. And the bottom one didn't change. So now, notice we have opposite x and y values. So now we just follow the steps we did previously. So then we're going to add the equations together. And we get negative x and negative 2x is negative 3x. These cancel out. And we get negative 11 plus negative 19 is negative 30. So we have negative 3x is equal to negative 30. Now we just solve. So we divide both sides by negative 3. And we get x is equal to negative 30 divided by negative 3 is positive 10. So there's our x value. Now we're going to plug that in to one of the equations and solve for the y value. So I'm going to go ahead and use my new equation. I can use the new equation or any of the two that I started with. I'm going to just use the new equation. That's fine. So I'm going to plug 10 in for x. So this is negative 10 plus y is equal to negative 11. I add 10 to both sides to get y by itself. And I get y is equal to negative 11 plus 10 is negative 1. So y is negative 1 and x is 10. Let's look at another example. We have 5x plus y is equal to 9 and 10x minus 7y is equal to negative 18. So again, check for opposites. Well, 5 and 10 are not opposites and 1 and negative 7 are not opposites. So I need to create opposites. So I could multiply this one here by negative 2. That would give me negative 10x and 10x. Or I could multiply it by 7, and that would give me 7y and negative 7y. I usually want to multiply by the smaller number because it keeps everything a little easier to manage. But it doesn't matter either way. This time I'm going to multiply by negative 2. So I get negative 2 times 5x is negative 10x. Negative 2 times y is negative 2y. And negative 2 times 9 is negative 18. So now I have negative 10x minus 2y is equal to negative 18. And the bottom one just drops down. So I have 10x minus 7y is equal to negative 18. And now I have opposite x values. So I can go ahead and add the equations. These will cancel out. I'm left with negative 2y plus negative 7y is negative 9y. And negative 18 plus negative 18 is negative 36. So now I just need to solve for the variable. So I'm going to divide both sides by negative 9. And I get y is equal to negative 36 divided by negative 9 is positive 4. So that's my y value. Now I need to plug it into one of the equations to solve for the x value. So I'll use 5x plus y is equal to 9. And I'm going to plug 4 in for y. So now this says 5x plus 4 is equal to 9. Well, now I need to solve for x. So I'm going to subtract 4 from both sides. And I get 5x is equal to 9 minus 4 is 5. Divide both sides by 5. And I get x is equal to 1. Now there's a video here that shows you how to check systems of linear equations in Desmos. So go ahead and watch that video. Let's talk now about how we can use Desmos to check our work when dealing with systems of linear equations. So first thing we're going to do is go to desmos.com, which is here, and we're going to click on Graphing Calculator. Now, this allows us to type in our equations over here. So let's go ahead and put in an equation. So let's say it's y equals 2x minus 4. So there's our first equation. Now we're going to type in our second equation. So we're going to go to the line below it. And let's say it's y equals negative 2x plus 4. So there's my two lines. And if I go to where the two lines intersect and click on it, I can see that it gives me the coordinates of exactly where the two lines intersect. They intersect at x equals 2 and y equals 0. So this would be the solution to my system of equations. And I can do this by inputting any two equations and then going to the point of intersection and clicking on it. It will tell me what the coordinate of that is with the x coordinate first and the y coordinate second.
So this is how you can check your work using does most when dealing with systems of linear equations.
Let's take a look now at the solving systems of linear equations using Elimination Part II assignment. The assignment begins with our learning goals and success criteria. If we scroll down, we can see the questions. Now it says to solve using elimination. So we got negative 4x plus 9y is equal to 9 and x minus 3y is equal to negative 6. Well, I can see that if I multiply this bottom one by 3, that gives me 9y and negative 9y. So I'm going to go ahead and do that. So this becomes 3x and negative 4x, so that's just negative x. These are going to cancel, and then we have 3 times negative 6, which is negative 18, plus 9 is negative 9. So we got negative x is equal to negative 9. So if we divide both sides by negative 1 to get rid of the negatives, then we get x is equal to 9. So it could be this one or this one. So we're going to plug that into one of the equations. So we'll pick this one. So we'll plug 9 in for x. So 9 minus 3y is equal to negative 6. I'll subtract 9 from both sides. And I'm left with negative 3y is equal to negative 6 minus 9 is negative 15. Divide both sides by negative 3, and I get negative 15 divided by negative 3 is positive 5. So x is 9 and y is 5, which is this one here. So we'll do that for each of these. We'll solve each of them, and then at the end, once we get to the bottom of the page and we've answered all the questions, we'll click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go, and then submit your work on Google Classroom.